Okay, class. Thanks for watching this. What this video is about is testing independence in a two-way table structure. And the one thing what we're talking about is testing independence. In this case, we're talking about animals versus whether you like or don't like. So I'm just going to call it feelings. Feelings about the animals in question. So when they ask you what are the variables of this two-way table, the categorical variables is animals for the cats and dogs, and I'm just going to call it people, whether they like or not. But we could say people's feelings. I called it feelings, so I'll just kind of write that there. Feelings of people, and we're of course kind of dealing with a standard 2 by 2 table. Now, to go about answering this question on an AP exam, really takes a bit of discussion. The key is you are looking at every combination of the different types of animals versus every combination of feelings. And so that means your first step is you really are going to ask yourself, okay, what's the probability of having a dog? What's the probability of having a cat? What's the probability of liking an animal? And what's the probability of not liking an animal? And then you have to look at every single one of these combinations as well. So the next thing we're going to look at is the probability of having a dog and you like it. The next one you'll test out is the probability of having a dog and you don't like. Now notice the little squiggly. The little squiggly here means it's a not, don't like. I just don't want to write it off, try to move it a little quicker here. Of course, you have to deal with the probability of a cat and liking the cat. And you have to deal with the probability of a cat and you don't like the cat. You don't like the cat. Okay, so these are the first 8 probabilities that you would have to figure out to make the connections to test all the cases of independence. So I'm doing a full-fledged testing situation of this entire two-way categorical table. So when I look at the information, I say, what's the probability of having a dog? Well, it's 27 out of 58. So I'm just going to write all these probabilities down. 27 out of 58. The cat is 31 out of 58. Liking, we're going to say it's 26 out of 58. Not liking is 32 out of 58. Okay, so it takes care of these. And now we have to look at the combinations. The probability of a dog and you like the dog, which is 12 out of 58. Dog and you don't like the dog is 15 out of 58. Cat and you like the cat is 14 out of 58. And the cat and you don't like the cat is 17 out of 58. So these are the sample probabilities that the evidence is giving us. And remember, we're trying to test independence. So what we're really after is the general rule. And what we're doing here is we're testing the general rule, the rule that the probability of A and B is in fact equal to, I'll get rid of this little part here, is in fact equal to the probability of A times the probability of B. And so we really have to go through 1, 2, 3, 4 tests of this fact. So we go through and I'm just going to say, I'm going to break them down into cases. Case 1, the probability of the dog times the probability of liking. And so I'll write down each one, 27 over 58 times 26 over 58. And I don't know if you're going to see this, but I'm going to use my calculator on the screen. I hope it does, but if not, You can do this on your calculator as well. So I am going to type in the information I'm after, which is 27 divided by 58. And then I'm going to multiply it. And I'm going to multiply it to 26 divided by 58. And I'm going to be very careful in my approximations, but I'm getting a 0.20860. 0.20860. So I'm really being detailed to get a couple decimal points to feel like I have a very strong case of accuracy. And now we have to finish the case, and we have to deal with the probability of the dog and liking. And according to this one, it's 12 over 58. And again, I'll put my approximation down, and I'll use my calculator, and it'll tell me that 12 divided by 58 is 0.20689. Now, if you were in my class, I told you that there is some evidence, or basically what we say here in this situation is we say that since these are not the same, we say they are not independent. But on a more advanced AP test, we would say there is little. Okay, so I'm going to write out the statement that I want to write. There is little evidence to suggest having a dog is not independent of liking animals. Okay, so this is actually to be specific here, I want to be not just liking animals. In this particular case, I'm going to say liking a dog, because now the reason I'm going to refer to these words is because I'm focused on liking dogs right now and not liking. So we have to go through each case. This was just the first case, and technically speaking, we can say we're done. We can say that the evidence suggests that animals liking or not liking animals is not independent of having a cat or a dog. But technically, we would have to go through all these cases. So you would have the second case. And I'll do the second case, and I'll assume you can get the idea for the third and the fourth case. But I'll go into the second case. And the second case would be the probability of liking a dog times the probability of not liking a dog. And we'd go through all the math again. And not liking in this case is 32, or pardon me, I'm sorry, not liking an animal. So, and not liking an animal is 32 out of 58. And when I check that, I'll go to my calculator, do it again. Just bear with me while I do the math as well. And I'm getting approximately 0.25683. But when we compare it to the actual data of the probability of having a dog and not liking the animal, sorry here, sorry class, it's got a little funny. Okay. We're going to get that, well, in fact, it's not an approximate. Actually, it's equal. We have the information. It's 15 out of 58. So I'm sorry about that.